Distinguished guests, ladies and gentlemen, I am honored, of course, to be the winner of the Blue Planet Prize, along with my colleagues here. It is something that is very important to have been recognized for the work in the last 25, 30 years, and will provide the opportunity for me to continue in the future in the same direction. Hopefully new directions. It's also a pleasure to speak at the prestigious University of Kyoto, where I've come before and whose reputation is a worldwide reputation. So this is an honor for me to be here. Data as a topic is not a very interesting topic, not a very exciting topic. Nobody wants to talk of data. It's a bit boring. And if you talk of data, then after a while, people start getting bored. They look at their iPhones, they think of their dinner, but they don't think of the numbers. They don't think of data, and they don't think of statistics. But today, data and evidence has become absolutely central for policymaking, and in almost all fields, but definitely in the field of disaster risk reduction, and rightly so. So disaster risk reduction, which is an important area of work which is developing right now, is an area of work that looks at how we can reduce the risk to communities in the world, in the countries, in regions, how we can reduce the risk of damage and losses from different kinds of natural disasters. So there are natural disasters which are climate-related natural disasters. So cyclones, different kinds of storms, other storms, droughts, floods, all of these kinds of climate-related natural disasters, but also geological natural disasters, such as volcanic eruptions or earthquakes, to which Japan is very familiar and has made very, very big progress in risk reduction. So disaster risk reduction today has become a very important topic because most of these disasters which are climate related, and we will look at some data later on, most of these disasters which are climate related are in fact on the increase in certain parts of the world. And we will look at why I say so significantly in certain parts of the world. MDAT, the disaster database that was referred to by the moderator, MDAT is a unique international database that collects data, compiles data on a systematic basis for scientific use on all natural disasters in the world. So the database covers about 184 countries who are members of the United Nations, 184 countries for all natural disasters, and the data goes back to 1900. So about 123 years of data collected for each natural disaster, any disaster event that has occurred in the world. So it starts from Tuvalu or Vanuatu, the smallest Pacific islands, to countries like Brazil, United States, and Germany. So the whole spectrum is covered. That is the disaster database, and what it has done very significantly, actually, for databases, global databases, is that it follows a standard methodology for the entire database. In other words, there has been quite a lot of criticism in the beginning, now no longer, criticism in the beginning, that, oh, but you're not including disasters in my country that has killed 3 people. And it was a very important disaster in my country. It was a small country, it's a very important disaster as well. We have something called a criteria for inclusion, right? So in other words, any disaster event that gets included in the MDAT database has to meet standard criteria. This is important. Why? Because then you can compare a disaster in Vietnam to a disaster in Canada, right? So every country becomes comparable because the criteria is the same. That's very important. The other thing that's important is classification. So we will look at the classification issues. So what are the disasters in MDAT database are classified into 6 major categories, big columns, as you see here. And then there are subcategories. And then again, there are second-level subcategories, which you're not seeing here. I don't want to overwhelm you with details, but there are subcategories. So each event is categorized into one big category, then into a subcategory, and then into a subcategory. This means that you can very clearly distinguish between coastal floods, riverine floods, plain floods, flash floods. So there are many other kinds of floods also. So you can distinguish if it's a researcher who's looking at specific kind of a flood, they can go into the database and distinguish between the exact kind of floods they're looking for. These subcategories, you will see almost of the 6 subcategories, all of these 4, the middle 4, are in fact linked to climate, right? So if you look at the first one, it's hydrological, categorized into floods, landslides, and wave action. The next is meteorological, this one. Meteorological, these are storms, extreme temperatures, so that's heat waves and cold waves, and fog. The third one is climatological, which includes droughts, glacial lake outbursts, and wildfires. And more recently, I'm sure that because of your news, even if you're not in this field, you will know that droughts and wildfires have become very, very important even in this region, or in this region, in the Oceania region and Southeast Asia. Wildfires in Australia and so on and so forth has been very, very important in Canada and Western Europe. The fourth group, which is biological, there are really only 2 that can be directly associated to climate: epidemics and insect infestation. What is an insect infestation? This is quite an important subcategory. These are, for example, locust attacks. In many countries, including India and including several countries in Africa, locust infestations can arrive and completely eat a whole season's harvest, food harvest. So it's a very important, and epidemics as well are climate related. Not all epidemics, but many epidemics are climate related. Vectors, change in mosquito populations, change in rat populations, all of those have an impact on disease spread. Geophysical, the only one which is really not related to climate are the geophysical ones: volcanic eruptions, earthquakes, and dry landslides. So if we look at human impact, so those were the classification for the disaster events themselves. If we look at human impact, how do these disasters impact people? We find that, in fact, a very large proportion, about 76% of people affected by natural climate disasters, so climate extremes, about 76% are affected by floods and droughts. So if we were all and only economists, we would then say that the most efficient way of dealing with climate, reducing the climate risk and climate impact, would be to concentrate on floods and droughts. If we concentrate on floods and droughts, we will in fact be impacting, we would be reducing this large portion of the affected population. The third group of affected population are storms. So floods, droughts, and storms actually make up, these are major climate extremes. There's no doubt about that. Now, those three make up almost nearly 90% of all disaster-affected people in the world. More recently, it would be interesting to note that extreme temperatures and wildfires, which were very small events for many, many years, very small events, today has become one of the most important ones. In the last 2 years, they have increased enormously, and these are probably the natural climate extremes disasters that we have to face in the future. Trends over the decades. So MDAT data also, as I said, because it uses standardized methodology, it can be used to look at trends, how things have changed, because the definitions and the criteria have not been changed over the period that this data has been collected, so they are comparable. So the biggest changes really have been in numbers of disasters. So in this decade, we had about 4,000, and it's almost doubled in this decade. And also the economic losses, which has almost doubled in the 2 decades, between the 2 decades. So in other words, it just shows that some of the impacts, especially economic losses, have been increasing very substantially. The previous slide showed the time trends. So how has it changed over time? This one shows a little bit the global distribution, so the pattern over the world. And here we see that the highest economic losses have been in the Americas, so North and South America, and in Asia. So one of them has had about 1.32 trillion. It's 45% of the total, and the other one has 1.26 trillion, about 43% of the total. Now, these can be a little bit misleading, because if one looks at the breakdown, over here, almost a very large proportion of the economic losses, very large proportion, are contributed by the United States. By the United States. I can't see exactly how much of it's there, but it's a very large proportion is contributed by the United States. In Asia, of the 126 trillion, almost 1 trillion is contributed by China and Japan. And the interesting part of this data, and which actually shows a little bit the weakness of MDAT, is that economic losses, the way it is reported today, is actually reflecting the wealth of a country. So the higher the asset value, so higher the value of your property is, of your land, of your agricultural land, I don't know, all of these asset values, the higher the value is of your house, the higher the value is, the higher the economic loss is going to be. So you will see that most of the economic losses are from rich countries, because rich countries have populations that are insured. So they have insurance for house, insurance for property, insurance for industry, so on and so forth. Peasants in Bangladesh have no insurance. Their houses are not insured. None of that data is coming into MDAT. None of that data is coming into MDAT. So all the poor people in the world who lose their houses, who lose their little plots of land because of a flood or because of a cyclone, none of that information is entering MDAT database. So this data is showing essentially that economic loss data is only reflecting the rich people. So as you see, in Africa, there's almost nothing. It doesn't mean that Africans do not have huge damages. Doesn't mean it doesn't have huge damages. What it means is that those are not reported. The distribution of average disasters per year by country, this is also an interesting, something's getting stuck here. This is also an interesting distribution problem. challenge. This is an interesting distribution, because if you look at this map, what do you see? You're seeing a very high number in the United States and in Southeast Asia, South and Southeast Asia, South and Southeast Asia. There are two aspects that make this map slightly misleading also. One aspect is the geography, the very fact that a country is in a highly disaster-prone area in the world. So very simply, some countries have the bad luck to be in a highly seismic area or in the volcanic ring of fire, you know, in the Philippines and that whole Indonesia, all of that region where there are a lot of volcanoes, their country is located there. They cannot pick up their country and go somewhere else for risk reduction. They are stuck there. So the geographies of the location of a country is a very big factor, which explains a little bit the dark colors in this area. These are all countries, they're small countries, but they are highly, highly disaster prone. And the second one is the fact that many of the countries that are highly disaster prone, dark countries, are very big countries, very big countries. And so the size of a country, so India, which covers a lot of land, United States, that covers a lot of land, which else? Russia, which covers China, not Russia, but Russia also, China, which covers a lot of land. As soon as you have a very large space of your country, you're simply attracting more disasters because you have a large space. So both the size of your country and the geography of your country, where you're located, makes a difference in the numbers of disasters that you're likely to see. The top line, this one, is in fact all natural disasters, right? So it includes climate disasters, and it includes geological disasters, so earthquakes, volcanoes, landslides, all of those. So the top line is all natural disasters. This line is only climate disasters, and that actually gives you a good idea of the way it was in the early part of the graph, which must be early 2000s, and what it's looking like over here. And what does it look like over here? It looks as though that the numbers of climate disasters is catching up to the total global disasters. So in other words, the share, the proportion of climate disasters, is coming very close to the total number of disasters. So the difference is becoming very small. So we are seeing today almost 80 to 90% of all natural disasters in the world to be climate-related disasters. The other important point that might be interesting is that in the last few years, there has been an increase. This increase is actually mostly driven by the climate disasters. So affected per event and deaths per event. These are two different indicators that is very frequently used. Affected per event. How many people have been affected, have to leave their homes, they've been injured, they've been not killed, but injured and, you know, homeless and so on and so forth, need food, they don't have any food for weeks. So how many people have been affected? And this line, the orange line, is the number of deaths. Now, we may just take a few seconds to look at these peaks. The deaths, the two peaks over here, actually, this peak and this peak, both these peaks, these are affected populations. They are very high peaks, very high peaks. So in other words, these are millions of people, not hundreds of thousands, but millions of people. Both these peaks actually represent droughts. Droughts and floods. These are the two natural disasters that create the greatest damage in the whole world, droughts and floods. Earlier on, we saw droughts, the numbers of droughts and floods. And the graph showed you how many there are. But even the numbers of people affected is droughts and floods. When there is a drought, especially in Sahel Africa, in sub-Saharan Africa, it affects a huge number of people. When there is a drought in India, it affects not 50,000, not 100 million, 300 million people. 300 million people. So huge numbers of people are affected by these phenomena. What do the curves look like? What does the trend look like by disaster type? So what are we seeing in the last 20 years? In droughts, in extreme temperatures, so heat waves, floods, in storms, in wildfires. And this graph shows you by disaster type. So this is floods, which is by far the largest numbers amongst all disasters. And it has been going up in this year, but this year has been, I think it includes 2020, 2022, there has been 2023, it'll go up again. And then these are storms. These are storms. Then at the bottom of the graph, you see that everything is sort of creeping along. The only one that has an uptick at the end is actually extreme temperatures. And you must be all aware, this is not something that, you must be all aware that heat waves have been a very important problem in this year. In the previous years, heat waves are a problem, a natural disaster that affects not only poor countries, but also the rich ones. Europe has seen some very bad ones in the last decade or 2 decades, and also the wealthier countries of the OECD countries, Japan, Australia, etc. They have all suffered from serious heat waves. And heat waves are going to be a very big challenge for us in the near future, because the methodology for heat waves, to measure heat waves, is extremely difficult, and we can discuss that later on at some point. So what are the main challenges for the quality of data on disaster impact? Sound methodology. If there is not a sound methodology which is standard and harmonized through the years and over the countries and across the natural disasters, nothing will be comparable. So any kind of trend analysis to see whether a disaster in a country, in your country, is going up or going down, if the methodology is not the same, 5 years ago, 10 years ago, if it's not the same methodology, it cannot be compared. And therefore, your analysis will be weak. Second is definition of variables and inclusion and exclusion criteria. This comes directly from epidemiology. It comes directly from clinical trials, of medical trials of pharmaceuticals. Inclusion and exclusion criteria is absolutely critical. So in other words, which disaster event is included in your disaster database and which disaster event is not included. There is a disaster and it is not included. There has to be very clear criteria saying we are not going to include this flood in Papua New Guinea because it does not meet our criteria. So this is something that is a very critical element for quality of data. Checking for validity, we can discuss this later on. The data that gets finally entered into the database has to be validated. And completeness and accuracy, when there is 184 countries to follow, and all of those different disasters, the data must be complete. You have to have it for all countries. We can't say that, 5 years ago we only had 80 countries reporting, and now we have 120, and tomorrow we have something else. No, there has to be all the countries. So those are very important, important issues. Now, I would like to point out that, all this data stuff that I've spent so many years working on, quality of data, quality of evidence, quality of analysis, results out, all of that boils down at some point to human welfare, to people, to human beings on the ground, to families, to households, to individuals on the ground. This data must mean something that changes the life of people on the ground. And here we see a young boy in floods. This is in Bangladesh, in floods. Now, what is the significance of this picture? The significance of this picture is that this child is hanging his clothes out, his family's clothes out to dry, standing in knee-deep water, and he is being exposed to several very important health hazards. This is a poor child. It's not a rich child, it's a poor child. Inside of his house is full of water. He's going to sleep inside there. And most likely, this child is going to sleep with wet clothes, because this is the only set of clothes he has, most likely. So he's going to be sleeping in wet clothes. Wet clothes, sleeping in wet clothes for small children or infants is instant exposure to bronchitis and pneumonia. And for malnourished children, pneumonia is a matter of 2 days, 48 hours to death, 48 hours. So it is an extremely fatal disease for small children with malnutrition. He is also exposed to all kinds of waterborne diseases. Diseases like leptospirosis, diseases like dengue, all of these diseases that are carried by vectors, mosquitoes, rats, and so on and so forth. So these kinds of situations have a huge impact on human welfare and must be addressed at the human level. The problem with global data, I'm just going through a little faster. The problem with global data like MDAT sees the world. We are doing 184 countries. It's all big world, global policies, and so on and so forth. If we look at the pattern by 3 decades at the global level, we see that the population affected by flooding is very gratifyingly going down. Every decade is going down. This is good news. We are all very happy. You go to the global meetings, summits, I don't know what, all kinds of climate summits, show this, looks good. But if that data is broken down to Africa only, if it's broken down to Africa only, what do we see? We see exactly the opposite. Exactly the opposite. We see that for every single decade, the number of people who are affected by flooding is actually going up. This means what? This means that global data has its limitations. Global data must be broken down to understand how things are actually evolving at the local level, at the regional level. I have worked a lot on the field. I go to the field very often. I still go to the field very often. It's important to go to the field. However big scientist you are and a very smart analysis you're doing, it is important to go to the field, because it's only by going to the field you have credibility of what you're saying, that you can tell people things and because you've seen it. And one of the things people always say that it must be very hard for you because it's disasters and it's very sad and tragic things. It is extraordinary, the amount of resilience and amount of imagination that local people have to find solutions. They will always find solutions. People find solutions. And that is the strength of communities. That is the strength of our world. Most of the people affected by floods in the last 3 decades at a global level have been, are reflected here in the yellow pillars. But then when we look at the people affected for each of the decades, we see that a very large proportion in the first decade was contributed by China and India. China and India, China and India, 2/3 almost, China and India. The next decade, the share of China and India is much less. And the third decade, it's very little, very little. It has become from this to this to this. It suggests that both these countries have made great progress in flood risk reduction. That is what it means. It means that both China and both India have invested in reducing the risk for floods. The last MDAT-based slide will be on extreme temperatures, because it is an important thing. Heat waves and, to a certain extent, cold waves are our biggest challenge in the next decade, biggest challenge. It is not only a challenge because it will increase, it is also a challenge because the measures to reduce the risk is very hard to implement, very hard to implement. In this graph, deaths per event is this line, and we see that deaths per event have been increasing in a very, very significant way. So the deaths related to heat waves is becoming very high per heat wave. So it's actually standardized a bit. Another critical gap in MDAT are the numbers of disasters which are not reporting any data at all. Not any data at all, but it's not reporting data on economic losses. So while we have pretty good data on deaths, number of people who have died, number of people who've been injured, our data on economic losses is not good at all. And as you will see, that Africa, nearly 90% are not reporting economic losses, and heat waves is not reporting. This has to change. This has to change. If we want to change policy, we need evidence. And right now, we don't have that evidence. Right now, we don't have that evidence. What is the future? What is the future for MDAT, and what is the future for not only MDAT, but for disaster, climate extreme data? The first phase for MDAT has been data from secondary sources. So where do we get our data? We get our data from different countries who reported to us and so on and so forth. Secondary sources, it's not our primary data. The phase 2, we are now looking forward to shifting to survey data. So do selective field survey, like these, satellite data, and the creation of data cooperatives. So we think most importantly, we need to bring people together, bring big data suppliers together. There are huge databases in Germany, in the United States, and so on and so forth. Bring them together and create cooperatives, not just one MDAT sitting alone, but making a club. Impacting policy, few research. I want to make a little qualification. Fundamental research is very important, absolutely critical. There is no question about it. But a lot of the research that we do has to have some impact on reality, on some impact on policy. We can't just sit and do our research thinking, oh, we are very good scientists, we are just doing our thing, and this is very important, and talk to each other. No, it has to impact policy. We have to do research for a change. And MDAT has been used in many different big forums because we are the only unique data source, but we also hold press conferences every year. I mean, after 2019, because of COVID, we did not have, but we use press conferences, and we do it together with the United Nations Disaster Risk Reduction Office, Secretariat. It's become very important right now. It wasn't 20 years ago. The Undersecretary General is Mrs. Mami Mizuturi from Japan. She has been heading it for now about 3 years, maybe a little more. And we hold a press conference in Geneva every year, and we provide to the press in January the trends and the patterns, like I showed, trends and the patterns of the world's disasters. I would like to end with that, but I would like to conclude with some summary conclusions. We need better models of socioeconomic impact. We have very good models of meteorological and climatological data, very good models, but we need better understanding of socioeconomic impact. We need to resolve methodological challenges that I mentioned earlier on, and we need much higher resolution data for subnational analysis, much higher resolution data on subnational analysis for disaster footprints and exposed populations. At the end of the day, all the work that we do, I started my career with working on humanitarian emergencies. As to go out, that's how I started. I went to Chad, I went to the famine thing, humanitarian. At the end of the day, however much we work at the global level and go to these important conferences for COP26, COP this, COP that, IPCC, and so on and so forth, at the end of the day, it's that little boy that we saw. He has to benefit. If we want change, if we want to have a reduction of global impact of climate change on populations, we need to impact on that little boy. That group of people have to feel the results of our research, and not the meetings in New York and Sharm el-Sheikh in Egypt. Thank you.
Debbie, thank you for a wonderful talk.